In this Easy Ed video lecture, we will see about engineering curves, in which we will see different curves such as ellipse, parabola, hyperbola, cycloid, epicycloid, hypocycloid, involute, spiral, and helix. First, let us see about engineering curves. Curves are basically non-circular. These curves are used in drafting machine components, elliptical gears, civil structure like bridges, arcs, etc., and in many other fields of engineering. Some of the engineering curves are conic section, curves, cycloids, involutes, spirals, and helix. These curves are generated by moving a point in a single plane, except helix, and so they are also called as plane curves. Firstly, we will see conic section. Various types of conic section is circle, ellipse, parabola, and hyperbola. These curves are called conic sections because these curves are generated by taking various sections of cone. A cone has apex, generators, axis, and base. When the cutting plane is perpendicular to the axis and cuts all the generators, the section obtained is called a circle. When the cutting plane is inclined to the axis of the cone and cuts all the generators on the side of the apex, the section obtained is called an ellipse. When the cutting plane is inclined to the axis of the cone and parallel to one of the generators, the section obtained is called a parabola. When the cutting plane is parallel to the axis of the cone, the section obtained is a hyperbola. What is an ellipse? Ellipse is defined as the locus of a point moving in a plane such that the sum of its distance from the two fixed points always remains constant. From the given figure, we can say that CF1 plus CF2 equals length of AB, that is CF1 equals half of length AB. Here, length AB and CD are major and minor axes of ellipse. Mathematically, an ellipse can be described by the equation x square by a square plus y square by b square equals 1. The ratio of the distance of the point from the focus to the distance of the point from the directrix is called eccentricity, and for ellipse, it is always less than 1. Elliptical shape is used in the construction, elliptical gears, of textile machine, bridges, arches, etc. Construction of ellipse is done by many different methods like focus directrix method, rectangle method, concentric circle method, arcs of a circle method. Hey, it's time to concentrate now. Let us first construct ellipse by focus directrix method. Consider the given data. The distance of the focus from the directrix is equal to 50 mm and eccentricity is 2 by 3. Also draw tangent and normal at any point Q on the curve using directrix. Step 1. Draw a vertical line AB and from point C draw a horizontal line. Step 2. Mark point F 50 mm from point C and divide the CF into 5 equal parts, sum of numerator and denominator. Step 3. Mark the vertex V on the second division point from F. Step 4. From V, draw a perpendicular line and mark point E such that VF equals VE. Join CE and extend it. Step 5. Now divide the line in equal number of parts to the right of F. Step 6. Now draw perpendiculars from this respective points. Step 7. Measuring distance 1, 1 dash, draw an arc from point F on either side. Similarly, measuring 2, 2 dash, draw an arc from point F on either side. Similarly, measure for point 3, 4, and so on, and draw an arc on either side. Step 8. With the help of the French curve, connect the points to get the required ellipse. Let us consider point Q anywhere on the ellipse. Step 9. Join point Q to F. Step 10. Construct 90-degree angle with this line at point F and extend the line to meet directrix at T. Step 11. Join this point to Q and extend it. This line is tangent to the ellipse at point Q. Step 12. From this point Q, draw a perpendicular line. This line is normal to the curve. This is the required ellipse. Next, we will draw ellipse by rectangle method. In rectangle method, lengths of major and minor axis are given. Consider the given problem. Draw ellipse by rectangle method. Take major axis 100 mm and minor axis 70 mm long. Step 1. Draw a rectangle taking major and minor axis as sides. Let the rectangle be PQRS. Step 2. In this rectangle, draw both axes as perpendicular bisectors of each other. Let major axis be AB and minor axis be CD. Considering left half of the rectangle. Step 3. Divide length AQ and AP into same number of equal parts, say 4, and name the points as 1, 2, 3, 4, and 1 dash, 2 dash, 3 dash, and 4 dash respectively, starting from A on AQ and AP. Step 4. Divide AO into 4 equal parts and name the points as 1, 2, 3, and 4. Step 5. Join 1, 2, 3 with C. Join D1 and extend it to intersect line C1. Similarly, extend D2 and D3 to intersect line C2 and C3 respectively. Step 6. Join 1 dash, 2 dash, 3 dash with D. Join C1 and extend it to intersect line D1 dash. Similarly, extend C2 and C3 to intersect line D2 dash and D3 dash respectively. Step 7. Draw a smooth curve through the points and obtain the left half of the ellipse. Step 8. Repeat the above steps and draw the right half of the ellipse, symmetrical to the left half. This is the required ellipse by rectangle method. Now, we will draw ellipse by concentric circle method. Draw ellipse by concentric circle method. Take major axis 100 mm and minor axis 70 mm long. Step 1. Draw a circle of diameter 100 mm and 70 mm. Let the center of the circle be O. Step 2. Draw both axes as perpendicular bisectors of each other. Let major axis be AB and minor axis be CD. Step 3. Divide both the circles into 12 equal parts and name them as shown. Step 4. From all points of outer circle, draw vertical lines downwards and upwards respectively. Step 5. From all points of inner circle, draw horizontal lines to intersect those vertical lines. Step 6. Mark all intersecting points properly as those are the points on ellipse. Step 7. Join all these points along with the ends of both axes in smooth possible curve. This is the required ellipse. Next method is arcs of circle method. Consider the given problem. Major axis AB and minor axis CD are 100 mm and 70 mm long respectively. Draw an ellipse by arcs of circle method. Step 1. Draw major and minor axis as usual. As per the definition, ellipse is locus of point P moving in a plane such that the sum of its distance between two fixed points F1 and F2 remains constant and equals to the length of major axis AB. Step 2. Taking AO distance, that is half major axis from C, mark F1 and F2 on AB. Step 3. On line F1O, taking any distance, mark point 1, 2, 3 and 4. Step 4. Taking distance as A1 and point F1 as center, draw an arc above the below line, AB, and distance as B1 and point F2 as center. Cut this arc and mark a point. Step 5. Repeat this step with same centers but now taking distance A2 and B2. Draw the arc and mark a point. Step 6. Similarly, get all other points. With same steps, position of points can be located above and below AB. Join all points by a smooth curve to get left half of the ellipse. Repeating the above steps, right half of the ellipse can be constructed. This is the required ellipse. What is a parabola? It is the locus of a point moving in a plane such that the ratio of its distance from a fixed point f to the directrix is constant and is always equal to 1. Here, V is the vertex, and the line passing from the focus and perpendicular to directrix is the axis of parabola. Equation of parabola is y square equals 4ax. Construction of parabola is done by three different methods: focus directrix method, rectangle method, tangent method. Hey, it's time to concentrate now. Let us first construct parabola by focus directrix method. Consider the given problem. Construct a parabola when the distance between focus and the directrix is 40 mm. Draw tangent and normal at any point Q on your curve. Step 1. Draw a vertical line AB and point C, draw a horizontal line. Step 2. Mark point F 40 mm from point C and divide CF in 4 equal parts. Step 3. Mark the vertex V on the second division point from F. Step 4. From V, draw a perpendicular line and mark point E such that VF equals VE. Join CE and extend it. Step 5. Along the axis line, mark points 1, 2, 3, 4, 5 at approximately equal intervals. Step 6. From points 1, 2, 3, 4 and 5, draw vertical line till it intersects line CE. Name their intersection as 1 dash, 2 dash, 3 dash, 4 dash and 5 dash respectively. Step 7. With C1 as radius and F as center, draw arcs on either side of the axis. Mark that point. Step 8. Now taking C2 as radius and F as center, draw arcs on either side of the axis. Mark that point. Step 9. Similarly mark points on line 3, 4 and 5. Step 10. Draw a smooth curve from these points to get the required parabola. Let us consider point Q anywhere on the parabola. Step 11. Join point Q to F. Step 12. Construct 90-degree angle with this line at point F and extend the line to meet directrix at T. Step 13. Join this point to Q and extend it. This line is tangent to the parabola at point Q. Step 14. From this point Q, draw a perpendicular line. This line is normal to the curve. Let us construct parabola by rectangle method. Consider a ball thrown in air which attains 100-meter height and covers horizontal distance of 150 meters on ground. Draw the path traced by the ball projectile. Step 1. Taking proper scale, draw a rectangle with base 150 meters and height 100 meters. Let the rectangle be ABCD. Step 2. Take midpoint as O and V on line AB and CD and join OV. Considering the left rectangle AOVD. Step 3. Divide line AD and AO into same number of equal parts, say 6. Step 4. Now join V1, V2, V3, V4 and V5. Step 5. From point 1 on horizontal line, draw a perpendicular line till it cuts line V1. Similarly, from point 2, draw a perpendicular line till it cuts line V2. Similarly, draw on points 3, 4 and 5. Step 6. From the given points, draw a smooth curve to get left half of parabola. Step 7. Similarly, draw the right half of parabola. This is the required path of the ball, parabola. Now let's construct parabola by tangent method. Draw an isosceles triangle of 100 mm long base and 110 mm long altitude. Inscribe a parabola in it by method of tangent. Step 1. Draw base of 100 mm and height as 110 mm and draw the isosceles triangle. Step 2. Divide its both sides into same number of equal parts, say 8. Step 3. Join 1 1 dash, 2 2 dash, 3 3 dash and so on till 7 7 dash. Step 4. Draw a smooth curve such that the curve is tangential to the lines. This is the required parabola. What is a hyperbola? It is the locus of a point moving in plane in such a way that the ratio of its distance from a fixed point f to the fixed straight line directrix is constant and is always greater than 1. Here, V is the vertex and the line passing from focus and perpendicular to directrix is the axis of hyperbola. Equation of hyperbola is given as x square by a square minus y square by b square equals 1. Hyperbola is used in the design of cooling towers. Construction of hyperbola is done by two methods: focus directrix method, rectangular hyperbola. Let us first construct hyperbola by focus directrix method. Construct a hyperbola when the distance between the focus and directrix is 50 mm and eccentricity is 3 by 2. Draw a tangent and normal at any point on the hyperbola. Step 1. Draw a vertical line AB and from point C draw a horizontal line. Mark point F 50 mm from point C and divide CF in 5 equal parts. Step 3. Mark the vertex V on the third division point from F. Step 4. From V, draw a perpendicular line and mark point E such that VF equals VE. Join CE and extend it. Step 5. Mark more points ahead of F at equidistance. Step 6. Now draw vertical lines from each and every point and name them. Step 7. Now taking distance 1 1 dash, draw an arc on either side of the line from point F. Similarly, take distance 2 2 dash, draw an arc on either side of the line from point F. Proceed further for the remaining points. Step 8. From the points given, draw a smooth curve. This is the required hyperbola. Let's consider point Q anywhere on the hyperbola. Step 9. Join point Q to F. Step 10. Construct 90-degree angle with this line at point F and extend the line to meet directrix at T. Step 11. Join this point to Q and extend it. This line is tangent to the hyperbola at point Q. Step 12. From this point Q, draw a perpendicular line. This line is normal to the curve. Now let us construct rectangular hyperbola. Construct a rectangular hyperbola when a point P on it is at a distance of 30 mm and 40 mm away from x-axis and y-axis. Step 1. Draw two axes x and y and mark the distance 30 mm on x-axis and 40 mm on y-axis and mark point P. Step 2. Now divide horizontal line in 3 equal parts and vertical line in 4 equal parts. Step 3. From point P, extend horizontal line and vertical line. Step 4. Join O1 and extend it to intersect the line. Join O2 and extend it to intersect the line. Similarly, join O3 and extend it and name the intersection points. Step 5. From point 1, draw horizontal line and vertical line till it intersect each other. Similarly, from point 2 and 3, draw horizontal and vertical lines till it intersect each other. Step 6. From the given intersection point, draw a smooth curve. This is the required hyperbola. Let us see what is a cycloidal curve. A cycloidal curve is traced by a fixed point on the circumference of a circle, which rolls without slipping along a fixed straight line on a circle. The circle which rolls along the line is called a rolling circle. It is also known as generating circle. The fixed line or circle is called baseline or base circle. When a circle makes one revolution on the baseline, it would have moved through a distance equal to the circumference of the rolling circle. Different types of cycloidal curves are cycloids, epicycloids, hypocycloids.
Seriously, pay attention. This is important.
Firstly, we'll see what is a cycloid. Cycloid is a curve traced by a point on the circumference of a circle, which rolls along a straight line without slipping. Cycloid curve is used in Kimbell Art Museum. Let us understand the construction of cycloid. Draw locus of a point P on the periphery of a circle which rolls on straight line path. Take circle diameter as 50 mm. Step 1. Draw a circle of radius 25 mm and mark its center as C. Step 2. Now draw a horizontal line of length equal to circumference of the circle, pi d, from base and from center C. Step 3. Now divide the circle into 12 equal parts and also the horizontal line into 12 equal parts. Name the points as C1, C2, C3 till C12. Step 4. Now join 1, C1, 2, C2, 3, C3 and so on till 12, C12. Step 5. Now draw the horizontal line from the points on the circle. Step 6. Taking center as C1 and radius as 25 mm, draw an arc on line which passes through 1. Similarly, take center as C2 and radius as 25 mm. Draw an arc on line which passes through 2. Similarly, take center C3 and radius 25 mm. Draw an arc on line which passes through 3. Follow the same procedure for points C4, C5, C6 till C12. Step 7. From the given points, draw a smooth curve. This is the required curve traced by a point P on the circumference of a circle which rolls along a straight line without slipping. Next, we'll see what's a epicycloid. Epicycloid is a curve traced by a point on the circumference of a circle which rolls without slipping on the outside of another circle. The fixed circle on the outside of which the generating circle rolls is called the base circle. Let us understand the construction of epicycloid. Draw locus of a point P on the periphery of a circle which rolls on a curved path. Take diameter of rolling circle as 50 mm and radius of directing circle as 75 mm. When the smaller circle will roll on larger circle, for one revolution, it will cover pi d distance on arc and it will be decided by included arc angle theta. Calculate theta by formula. Theta equals radius of rolling circle by radius of directing circle into 360. On calculating, we get the value of theta as 120 degree. Step 1. Draw line OPC such that OP equals 75 mm and PC equals 25 mm. Step 2. Take C as center. Draw a circle of radius 25 mm. Step 3. Through point P, draw an arc. Now mark point Q such that angle POQ equals 120 degree. Step 4. Draw an arc through point C. This line is called locus of center C. Step 5. Now divide the circle into 12 equal parts and also arc PQ in 12 equal parts. Name the given points as shown. Step 6. Extend line O1' till it meets locus line at C1. Similarly, extend O2', O3', O4' till O12'. till it meets locus line at C2, C3, C4 till C12. Step 7. From points 1, 2, 3, 4, 5, 6 on the circle, draw arc through each point specified. Step 8. Taking C1 as the center and radius equal to 25 mm, draw an arc cutting the arc through 1. Now taking center as C2, draw an arc through 2. Now taking center as C3, draw an arc through 3. Similarly, mark points from center C4, C5, C6, etc. Step 9. From the given points, draw a smooth curve. This is the required epicycloid's curve. Next curve is hypocycloid. Hypocycloid is a curve traced by a point on the circumference of a circle, which rolls without slipping on the inside of another circle. The method for construction hypocycloid is the same as epicycloids. The center C of the generating circle is inside the directing circle. Draw locus of a point P on the periphery of a circle, which rolls from the inside of a curved path. Take diameter of rolling circle as 50 mm and radius of a directing circle as 75 mm. When rolling circle rolls inside the directing circle, completing one revolution, it covers pi d distance on arc, and it will be decided by included arc angle theta. Here, the value of theta is 120 degree. Step 1. Draw line OCP such that OP equals 75 mm and PC equals 25 mm. Step 2. Taking C as center, draw a circle of radius 25 mm. Step 3. Through point P, draw an arc. Now mark point Q such that angle POQ equals 120 degree. Step 4. Draw an arc through point C. This line is called locus of center C. Step 5. Now divide the circle into 12 equal parts and also arc PQ in 12 equal parts. Name the given points as shown. Step 6. The intersection of line O1 dash, O2 dash, O3 dash, O4 dash, etc. with locus of center C are C1, C2, C3, C4, etc. Step 7. From point 1, 2, 3, 4, 5, 6 on the circle, draw arc through each point specified. Step 8. Taking C1 as the center and radius equal to 25 mm, draw an arc cutting the arc through 1. Now taking center as C2, draw an arc through 2. Now taking center as C3, draw an arc through 3. Similarly, mark points from center C4, C5, C6, etc. Step 9. Draw a smooth curve from these points. This is the required hypocycloid's curve. Next curve is an involute. Involute is a single curved line traced out by an end of a string when unwound itself from a circle. Involute of a circle is used as a profile of gear teeth. Let us first construct involute of a circle of diameter 30 mm. String length is equal to the circumference of the circle. Step 1. Draw a circle of radius 15 mm and mark its center as O. From the base of the circle, draw a straight line equal to length pi d. Step 2. Now divide the circle and straight line into 12 equal parts and name the points as shown. Step 3. Now draw tangents through points 1, 2, 3, 4, 5, etc. Step 4. On line 1, mark a point equal to length P1 dash. On line 2, mark a point equal to length P2 dash. On line 3, mark a point equal to length P3 dash. Similarly, mark a point on line 4, 5, 6, 7, etc. Step 5. Draw a smooth curve through the points. This is the required involute curve of a circle. Now we will construct involute of a square. Consider a square of side 30 mm. Construct its involute profile. Step 1. Draw a square A, B, C, D of side 30 mm. From point B, draw a straight line equal to length of perimeter of a square. Step 2. Now extend line DA, line CD and line BC. Step 3. Mark a point on line from A such that its length is equal to AB. Mark a point on line from D such that its length is equal to AB plus AD. Mark a point on line from C such that its length is equal to AB plus AD plus CD. Step 4. From the given points, draw a smooth curve. This is the required involute curve of a square.
Seriously, pay attention. This is important.
Let us now see an involute whose string length is more than the circumference of circle and less than the circumference of circle. For such cases, always remember whatever may be the length of the string, mark pi d distance horizontal, that is along the string, and divide it in 8 numbers of equal parts. Rest all the steps are the same as previous involute. Next curve is spiral. Spiral is defined as the locus of a point which moves around a center called pole while moving towards or away from the center. The locus of the point from one complete revolution of the radius vector is called spiral for one convolution. There are two types of spirals: Archimedean spiral, logarithmic spiral. Let us construct Archimedean spiral first. Draw a spiral of one convolution. Point O moves away from the pole and reaches a distance of 40 mm. Step 1. Draw a circle of radius 40 mm. Name its center as O and endpoint as P. Step 2. Divide the circle into 8 equal parts. Also line OP into 8 equal parts and name the points as shown. Step 3. Taking distance O1 on line OP, draw an arc till it cuts line O1. Taking distance O2 on line OP, draw an arc till it cuts line O2. Now taking distance O3 on line OP, draw an arc till it cuts line O3. Similarly, mark points on line O4, O5, O6 and O7. Step 4. From the given points, draw a smooth curve. This is the required spiral. Final curve is the helix curve. Helix is defined as a curve generated by a point moving around and along the surface of a right circular cylinder or cone with a uniform linear velocity in the direction of the axis. Helix is widely used in helical spring, worm gears, spiral stairways, etc. Types of helix are cylindrical helix, conical helix. Let us first construct cylindrical helix. Draw a helix of one convolution upon a cylinder. Given 80 mm pitch and 50 mm diameter of a cylinder. Step 1. Draw a cylinder of height 80 mm and base 50 mm. Draw a circle of 50 mm diameter to represent top view of cylinder. Step 2. Divide the circle into 8 equal parts and also the height of the cylinder into 8 equal parts. Name the points as shown. Step 3. Draw a horizontal line from the points on the cylinder. Step 4. From point 1 on the circle, draw the projection till it cuts line 1 on the cylinder. From point 2 on the circle, draw the projection till it cuts line 2 on the cylinder. From point 3 on the circle, draw the projection till it cuts line 3 on the cylinder. Similarly, mark points 4, 5, 6, 7 and 8. Step 5. From the given points, draw a smooth curve. This is the required cylindrical helix. Now let us construct conical helix. Draw a helix of one convolution upon a cone of a base diameter 70 mm, height 90 mm, and pitch 90 mm. Step 1. Draw a cone of base 70 mm and height 90 mm. Step 2. Draw the top view of the cone as a circle of diameter 70 mm. Step 3. Divide the circle into 8 equal parts and name them as shown. Step 5. From the points on the circle, draw their projection in the front view of the cone as shown. Step 6. The intersection of the projection line 1 on generator 1, projection line 2 on generator 2, projection line 3 on generator 3, and so on till projection line 8 on the apex. We get points on the cone. Step 7. From the given points, draw a smooth curve. The first half of the curve will be seen, whereas the second half will be dotted. Step 8. Through point 1 on the curve, draw the projection till it meets line O1. Through point 2 on the curve, draw the projection till it meets line O2. Through point 3 on the curve, draw the projection till it meets line O3. Through the point 4 on the curve, draw the projection till it meets line O4. Similarly, obtain all other points. Step 9. From the obtained points, draw a smooth curve. This is the required conical helix curve. Let us take a quick review of what we've learned in this lecture. We have seen that curves are basically non-circular in shape. These curves are used in drafting machine components, elliptical gears, civil structure like bridges, arcs, etc., and in many other fields of engineering. Next, we have seen conic section curves. Conic section curves are circle, ellipse, parabola, and hyperbola. These curves are obtained when the surface of a cone is cut by some typical cutting plane. Next, we have done construction of ellipse by 4 different methods: by focus directrix method, by rectangle method, by concentric circle method, and by arcs of circle method. Construction of parabola by 3 different methods: by focus directrix method, by rectangle method, and by tangent method. Construction of hyperbola by 2 different methods: by focus directrix method and rectangular hyperbola. Next is cycloid curve. Cycloid curve is a curve traced by a point on the circumference of a circle, which rolls along a straight line without slipping. Also, we have seen construction of cycloid, construction of epicycloid, and construction of hypocycloid. Next curve is an involute. Involute is a single curved line traced out by an end of a string when unwound itself from a circle. Involute of a circle is used as profile of gear teeth. Also, we have constructed involute of a circle and a square. Next curve is spiral. Spiral is defined as the locus of a point which moves around a center called pole while moving towards or away from the center. The locus of the point for one complete revolution of the radius vector is called spiral for one convolution. There are 2 types of spirals: Archimedean spiral, logarithmic spiral, in which we have done construction of Archimedean spiral. Finally, we have seen helix curve. Helix is defined as a curve generated by a point moving around and along the surface of a right circular cylinder or cone with a uniform linear velocity in the direction of the axis. Helix is widely used in helical spring, worm gears, spiral stairways, etc. And also we have seen construction of cylindrical helix and conical helix. So this is the overview of our video lecture.